So now a quick second derivation for us. What if we have initial conditions? So when we find a transfer function, we always assume that the initial conditions are 0. But let's go back to the time domain, and rather than having a standard u of s, we're going to go back to the time domain by multiplying y of s over tau s plus 1 and u of s times a. And if we go back to the time domain, that's going to give us tau times y dot plus y of t is equal to a times u of t. So now if we go back to the Laplace domain, we say this time we do have initial conditions. We're going to have a component minus tau y0. So now y of s will be equal to a u of s over tau s plus 1. And that a u of s over tau s plus 1, that's going to be determined on our input, which is what we've been talking about in class. But the portion that's relative to our initial conditions will be that tau y initial over tau s plus 1, which we can simplify as y initial divided by s plus 1 over tau. And that's just going to say that whatever our initial condition is going to deteriorate over time, and it will take roughly 4 tau for 98% of it to deteriorate. So if we just look at that initial condition, we'll see that it will go to 0 over time, because for a stable system, that's what initial conditions do, which is why we're able to just kind of ignore them for our transfer functions, depending on the system. You know, if you're doing something medical or something very detailed, we might want initial conditions. We're going to learn how to handle them in the future, but that's why we're able to do this with transfer functions. Another thing that we can quickly point out is that if we have an initial condition, since it is going to 0 at the same rate that our equation is going to AB, if we have u of s is equal to a step function, that means we could just have our equation, it'll follow that same first order system curve by having y initial to AB. And you could think of that by either combining the fact that our initial conditions deteriorate, or by representing your entire function as delta y, where it's delta y from y initial will travel, it'll take 4 tau to go the distance from y initial to AB. So we see that if we wanted to represent everything with initial conditions as delta y, that would be a way to handle that. But that's one of the reasons that we are able to ignore initial conditions.